The topic of the session is trigonometry. What is trigonometry in mathematics? What is trigonometry? Trigonometry has been derived from three different words: trigonometry. The trigonometry has trigonometry. Now, tri is 3, which is a three-sided figure, which is a triangle. We know that a three-sided figure is a triangle, and gono is angle, and metry is measure. So with these three basic words split out of trigonometry have their own individual meanings. Tri is 3, gono is angle, and metry is measure. Measure of three angles of a triangle is called trigonometry. So trigonometry split as trigonometry is measure of three sides or measure of three angles of a triangle is called trigonometry. In general, what is the purpose of trigonometry? Why did mathematicians effort in researching on identifying the topic of trigonometry? What was the need for mathematics or the branch of mathematics to come out with the purpose or the reason for identifying this topic and its significance in daily life is the biggest question out here. The purpose or the need for trigonometry. Imagine, let's come out with a small activity to understand why trigonometry is very important in daily life. Say, for example, imagine I go into the deep forest and then I just come into a place where I have a small lake bed where all water is flowing in the lake bed. So here is the lake bed, and here is all the forest complete, and even the other side there is the forest out there. So I was going on a trekking on my trip, and then I just came till here and I was halting to know how I can cross to the other side of the small lake bed or the river flowing canal to go to the other side of the forest. So I was puzzled on imagining that I can do that if I put some wooden log out here, and then this wooden log on which I'm going to crawl or walk carefully to go to the other side. To do this mathematically, I paused for a while to imagine how much of the wood or the log of wood I can put on this canal bed to go to the other side. I wanted to estimate the length of the wood log I need to put on the river flowing small canal. So this puzzled me because I couldn't exactly measure the length of the width of the canal or the width of the river flowing there by just measuring with a tape, because I cannot do that manually, because for a while I don't have the log here. So how do I find the length, the width of this using the mathematics or the branch of mathematics is the biggest question when I go and stand at the bank of the river this side. So these kind of questions were big puzzles in identifying how we can successfully go to the other side of the forest. This can be done, and this is strictly possible if we know the topic of trigonometry. Trigonometry helps us in estimating this distance without actually measuring it. The power of trigonometry is to measure these distances without actually measuring with tape. Imagine I have a long tower, say it is a Qutub Minar. I have a Qutub Minar here, and then I stand here. I just stand here, and then I want to find the height of the Qutub Minar by just standing out here, which is just 5 meters away from here or 15 meters away from here. Then how do I find the height of the Qutub Minar without actually measuring with tape? It is possible using the topic of trigonometry. Trigonometry is how we introduce the concept of trigonometry, which solves many problems like finding the height of the Qutub Minar or crossing the length of the river onto the other side, by crossing to the other side of the forest by just estimating the width of the river. So all these real life puzzles or tasks can be overcome if we know the concept of trigonometry applied in real life. Let's consider a right triangle and see how the real life puzzles can be solved using trigonometry connected with right triangle. So let's see how a right triangle is connected with the trigonometry. To come with this real life example, if this is the Qutb Minar, the height of which we need to find, imagine we can convert this real life puzzle into a right angled triangle or a right triangle. If the person standing here is watching the top of the Minar, then this being perpendicular clearly makes me understand that this real life problem can be converted into a right angled triangle. This being the height of the Qutb Minar, and this being the distance from the person to this, and this being the distance from the eye to the top of the Minar, as can be taken. Therefore, if I take a right angled triangle with vertices A, B and C, then there are three important factors we must know in right angled triangle. If this angle is 90, then in this case of the right angled triangle, if angle A is 90 degrees, then BC is called the hypotenuse because this is opposite to 90 degrees. The side opposite to 90 degrees will always be the longest side in a right angled triangle, and that side is called the hypotenuse, the longest side. So BC is called hypotenuse next. If I take this angle as theta, then that means the angle which the person is making with the top of the minar is theta, then the angle which the person makes will be considered as angle ACB or angle C, which is theta. So using this, we understand that any side opposite to this angle is called opposite side. This, of course, is hypotenuse, and this is called adjacent side. So these are the three sides which are very important out here, because this is called opposite side, this is called hypotenuse, and this is called adjacent side. Opposite because this side is opposite to angle theta, hypotenuse because this is opposite to 90 degrees, and finally the third side, which is this, is called adjacent side. This is just adjacent to the angle. So BC is hypotenuse, AB is opposite side, and AC is adjacent side. Is how we get each of the sides, hypotenuse, opposite and adjacent, this being the angle. Therefore, if suppose I have a triangle with angle out here, then in this case, this being 90, I understand that this is hypotenuse, usually hypotenuse denoted with H, and opposite side denoted by O, and adjacent side denoted by A will have its opposite side here and adjacent here. The opposite side comes here because the angle theta is here, and opposite to that would be O, is how we get. Suppose I have a triangle, say, so this is 90 and this is theta, then clearly angle 90 degrees opposite to that will be hypotenuse, opposite to theta is O, and this is adjacent, is how we understand the different right angle triangles taken in different forms, finally giving us the opposite side, adjacent side and hypotenuse for a right angled triangle.